have to share a little story with you. I met Dr. Christian a long time ago. I was fortunate enough to be one of our 4-H and FFA students that got to come to what's now called the World Pork Congress, and I heard him speak, and he sort of did a hands-on demonstration about selecting gilts and things like that. And so I went back home, and I was going to get into the pig business. And so I won't tell you how old I was, but it was in the 70s, so you can figure out about how old I was. But I didn't have quite enough money. This is a true story. And so I didn't really want to ask my mom and dad for money. But they did give me money to buy my high school class ring. And guess what I used the high school class ring money for? So I brought two bred gilts, and that was my introduction into the swine industry. It's a true story. It's quite interesting when we came home, and the guy delivered the gilts, and my mom goes, "What's this?" And I go, "That's my high school class ring, Mom." And she just shook her head, but my dad laughed. So anyway, so I guess it all turned out pretty well anyway. What I'm going to do today is share with you some work that we kind of have in progress. It's really quite interesting, and it's one of the things I learned over the years is sometimes that we just have to go back to where things are being done and just sort of take notes. And so I want to set you up is that here we have potentially 2 replacement gilts. They've been delivered from the multiplier, or you've bought them from a commercial supplier, and you're going to get ready to manage them. And a lot of people want to know or think about what are the ways we need to manage them to make sure they stay in the herd for a long time. And then we've done some work that would suggest that the way they were managed before you got there could influence that as well. And so this is kind of how I summarize it very briefly, is that when we talk about sow longevity, we have a developmental period. It actually probably begins when that future replacement gilt is fertilized. It continues as she develops in the sow's uterus, and then after she's born until she reaches puberty. Then after that, and she's delivered to the commercial farm, how she's managed has a big impact. So I call that sort of pre-farm delivery the developmental period, and that post-farm delivery the functional period. And so really, I think it's kind of interesting if we could come up with some things that we should do developing those replacement gilts, and then maybe we should come up with some things that we should or maybe shouldn't do after they arrive at the farm, and then try to look to see if there's an interaction between the two. Okay? And so we were thinking about how to do this, and our really approach is to go where the action is or where things are happening. So this is a study that's funded by our local Pork Council in North Carolina. We also have money from the National Pork Board, and it's what I call sort of a survey or retrospective study. And so what we're doing is we're We're tracking gilts through the multiplication phase. This is a production system that has its own internal multiplication. We're taking cohorts of gilts, actually litter mates. We're sending one of them to a commercial farm that has fairly low long longevity as we consider it. Their retention rate, they have about 8% of the sows that farrow 6 litters. We're sending the other one to a farm that I call high sow longevity. It's probably average or maybe just a little bit below average compared to the industry. In that basic study, we have the longevity is about 28% of the sows farrow their 6 litters. Okay, and what we're doing is we're just measuring things and watching and sort of trying to find differences. And this has been very kind of interesting for us, and we're not all the way through the study yet, but I think enough has come up to show us, to give us an idea of where we need to look for maybe things to do to keep sows in production longer in both places. And so that's kind of what I'm going to share with you today in the time we have. So just so you'll know, we're measuring lots of things at the multiplication phase. We're measuring all kinds of growth, body composition things. We're also trying to figure out how they respond to gonadotropes. I'm not going to talk about that today. And then what you're probably more interested in is in the functional phase, because I imagine that's what most of you are involved with. Once they get to the farm, we're really trying to sort of objectively evaluate things that most people may take for granted. So we're trying to quantitatively assess estrus scores and breeding scores. I'll show you how we do that in a few minutes. We're measuring all the things that think about during lactation that can influence sows and how they do. We're also recording environmental parameters, how they foster the animals and things like that. And so what we're really trying to do is try to find out what characteristics are the same between these farms that differ quite a bit in sow longevity and what ones are different. Okay. And so here's where we are right now. The study's going to have about 1,000 gilts total with 2 replicates. We're going to have one replicate that was born and then sort of matures where they'll have to be bred in the summer because that's a big problem for us in North Carolina. And then we have another one that was born where it matures in the spring, so to speak, or the fall where they aren't exposed to the heat. So we've had our first replicate, about 512 gilts that we've got all the information from in the multiplier phase. And then we split those gilts. We sent them to the 2 farms, and they've just been rebred after their first lactation. So I'm going to share that data with you today. As many of you know, in sow longevity, that first lactation seems to be the biggest hurdle. If you can get them through the first lactation, then the fallout isn't quite so great. So we've got some interesting information I'm going to kind of share with you. I'm going to show you lots of pictures so you can kind of get a feel for what the farm does. And it could be the same, and it could be quite different than what many of you do on your farm. So just to give you a background, when they come out of the multiplier, they're about 230 pounds, 6 months old, give or take, half a month or so. They don't get any boar exposure in the multiplication farm. So they're delivered on the trucks. When they get to the commercial farms, that's when they get their first boar exposure. And then there are some culling decisions that are made before they actually are delivered to the commercial farm at the multiplication phase. It's probably common things that many of you might do to deal with feet and leg structure, underlines, and infantile vulvas. And so those gilts that are culled out at the multiplication phase, they're not included in the study because they never go to the commercial farms. So here are the standard operating procedures for once they arrive at the commercial farms, and I'll show you kind of how they do these things. They do what we call, they skip heat on the first estrus. So once they record an estrus event on the gilts, then the gilts are actually bred on the second or third estrus. They're not bred on the first estrus detected on the farm. We assume that's its puberal estrus, but we don't know. Then after they're bred, they're actually bred in a pen for their first mating. And then once they're bred in the pen, I'll show you how they do that in a few minutes. They'll move them into a crate. They get their second mating in a crate. And then about 2 weeks after the breeding's done, they're actually moved to a gestation crate where they stay until they go into farrowing. So that's kind of how they do that. One other thing they do a really good job on both these farms is that once the gilts come in and they record an estrus event, those gilts go into another pen, and so then they keep the gilts that they haven't recorded an estrus event in a separate pen. So once the gilt's found in heat, they move her to another pen, and then so they put most of their efforts on the gilts that they haven't recorded estrus event. So this is what the breeding barn looks like, floor diagram. It's an old Lubbock system. If any of you have those, they never really make the conversion. So this is the gestation part of it. These are the breeding area here. If you notice the old Lubbock systems, they have the stalls in front and they have the pens behind them where you'd back the sows out to the pen and then breed and then put it back in. Well, they've actually, because of AI, they don't have as many boars, so they've actually converted this area here into their gilt developer. So all the gilts that come in from the multiplier on this section right here, they're in pens, and then they're moved. Once they're found in heat, they're moved to another pen, and then once they're bred, they're moved into a crate. And the gilt breeding and management's really kept separate from the sow. So that's kind of how they do things on that farm. So here's what we have so far. I'm going to show you this in terms of percentages. And we're going to work through this, and I'll talk about difference in each phase. And so ultimately, this study is going to go through 6 parities, and I've outlined that down here. So hopefully we'll get some data at the end of this to see how many actually farrow a 6th parity. So the same number starts out that it was actually enter or delivered to the farm, and then we actually see the number that were actually bred. So the difference between the two you can see there. We'll talk about in more detail later. And then of the ones that are bred, you can see that they're starting to separate out the difference the ones that farrowed, and then we've actually got the rebreeding data. So you can see on the high longevity versus the sow longevity, you're getting a split of anywhere after the rebreeding of the first parity of about 80% roughly of the gilts are still in production that came in, and then here you're down around 60. So you're getting about a 20 percentage point difference. If you remember the slide that I showed you at the very beginning, at the end of 6 parities, usually in the one farm there's about 8%. On the other farm it's about 28%. So we already got that 20% difference, it looks like, thus far. So if that holds true, we'd expect that to hold true through the rest of the study, but we're not sure. So a couple of things. What I've done in all these slides, I'll set them up for you. I'll show you a little bit and then talk about them in more detail. I've shown you the percentage of gilts that are bred that were delivered between the two. Here's a little bit about how they handle the gilts. Pen density, pen size. I've recorded high-low temperatures during the period of time the gilts were in the barn for you, so you kind of get an idea of the variation. And then there's a little bit about management, and then with heat checking here. What I've done is where the things either weren't different statistically thus far, or they weren't different in the actual things they have done, I've listed those things in the dark black, and then where things were different, I've highlighted one in blue and one in red. So when you scan through and see the red versus the blue, those are the things that were different either statistically or in how they do things. So you can see that right off the bat, there's pretty close to a 10% difference in the gilts that are delivered that never get bred between the farms. So 93% of the gilts that get delivered get bred as gilts on the high longevity farm, and only 80% or so. Really, 8 versus 10 in a 12 by 12 foot pen, that is, they give the gilts a little bit more space. I don't really think that has much of a physiological significance. If you calculate the square footage, they have plenty of square footage, 8 versus 10. High-low temperatures are the same. One of the things that's different about the high longevity farm than the low longevity farm is they have one person designated that does all the estrus detection and all the breeding on the gilts on that farm. And that's that person's job. Their main job is to check the gilts, breed the gilts, to know the gilts. Whereas on the low longevity farm, it's kind of whoever's turn it is, whoever is not working with the sows, work with the gilts. So that's one of the first things with those gilts that come in. There's a dedicated person, and that's their job. And that's all they do. You can see what I mean by this is gilt estrus breeding separate from the sows. What I mean by that is both barns keep their gilts totally separate. So they're not checking one pen of gilts and then one pen of sows, or one row of gilts and one row of sows. The gilts are entirely separate barns, so they're separated from the sows. And then you see the daily boar exposure. This is interesting, and it's just the opposite of what I thought it should be, being a reproductive physiologist. The heat check boars on this high longevity farm are actually young boars. They're young boars that kind of didn't make the cut, so to speak, either genetically or for whatever reason, to be in the boar stud. So after isolation and the first couple of times they collected the semen, these boars didn't make it, so they're shipped to the commercial farms to be heat check boars. Whereas on the second farm, they get boars that are actually called out of the stud, probably because of genetic reasons. So these are the older boars. These are the younger boars, about a 10-month difference. Most of the time we'll tell you that older boars make better heat check boars. I still believe that's true. The interesting thing about this is they actually kind of reward the boars. Every so often after they've done the job of heat checking the gilts, they'll collect the boar. They have a dummy there, and I guess that keeps the boars happy, you know. I don't know. So, I would say that when we watch the boars work the gilts and how the gilts respond to the boars, the one on the high longevity farm does a lot better. Now, what I'm curious about, I don't know if the size difference comes into play. So these young boars are closer to the size of the gilts than these older boars. And so I remember back when I had my 2 gilts, and we were breeding everything naturally, if I turned a big boar into my little gilts, sometimes I thought they were scared. So I don't know if that has anything to do with it or not. That's one of the differences that we found thus far. So then I was telling you about our scoring system, and we've used this over a number of years. And what it helps us do is really try to quantify different parts of the breeding process. And so what we do is we have a real simple system. We score matings or estrus detection on three things. The initial reaction to the boar, the maintenance of the standing reflex while the animal's being bred or after heat detection, initial heat detection, and then how well the sow or gilt accepts the semen. And so you can see our sort of rating here. 1s are actually good and 3s aren't so good. Okay, and so probably most of you that have bred sows know exactly what I'm talking about. When we have one that locks up immediately, we have some that kind of show the standing reflex, not until you put back pressure on. And then certainly with acceptance of semen or maintenance of the standing reflex, we have some sows that stand like statues and don't move, even if the boar wanders off. We have others that sort of lose interest when the boar moves away. And then we have some that we think are in heat. They kind of lock up, but they still don't lock up even really good when the boar's right in front of them. And so we use that, and we've gone into these two farms and tried to score all the matings and the estrus events on these gilts that we've seen. And I'll show you what we do. So the way I'm going to show you this is kind of like a chart. This is actually how they do the first breeding, right here. So I tell my students that when they do AI and estrus detection, they have to be the boar. And this may be taking it a little bit to the extreme. But that's how they breed the sows. They have the workers get on the backs and breed like that. They have the belts around them to keep the pressure, and this is what they actually do on both these farms. So the way I'm going to set this up is, remember in the gilts we have the first estrus and they're not bred, and then you come back and they're bred on their second estrus. So this would be for the first estrus. Here's our scores, 1, 2, because with initial reaction to boar we don't have a 3, and then we have the rest of them. And then I've put the average of those gilts for each farm kind of on a scale from 1 to 3 so you can see. And so you see that the obvious thing here is that it appears on this high longevity farm, for whatever reason, the estrus response is better and the breeding scores we have are better in terms of the initial reaction to the boar, how they hold that, and also the acceptance of semen. Okay? Now, these aren't bad, I wouldn't say, on the low longevity farm, but they're not anywhere near as good as on the high longevity farm. Okay. So again, just to remind you what that is, the 1s, we're really between 1 and 2. So you're really talking about, if I was grading students, we're really talking about an A, probably versus a C+ in a class, since I spend a lot of time talking with students. And so there's the scoring system again. Okay. So after the sows are after the gilts are bred, then hopefully the management of sort of these first parity sows that haven't farrowed yet. Here's typically what they do. As I mentioned earlier, they keep them in crates for 2 weeks. They detect pregnancy at 28 days with real-time ultrasound. A third party comes in to do the ultrasound. They have a technician that travels to all their farms that does the ultrasound. And then they adjust feed levels according to body condition. Obviously, with gilts during their first pregnancy, there's not a lot of adjustment that needed. They come in pretty good body condition, and they maintain the body condition through that first pregnancy fairly well. So again, just to remind you what the barn looks like, they would move them from here, and then they would load these gestation stalls as they come open, depending on where they were bred. So that would be the movement part. That's what the gestation barn looks like, the long rows of crates and things like that. They're low backs. The crates are a little bit wider than your average gestation crate that you've probably seen. They're about 32 inches, 34 inches, somewhere in that neighborhood. So we're at this part of the curve from here, from when they're bred, to actually which ones farrow. And you can see that the graph really doesn't seem to change that much. These two lines are almost parallel. And when we look at things done, you can actually see that I term this gestation losses. So in the high longevity farm, about 9% of the bred gilts fall out. In the low longevity farm, it's 11%. Temperatures really aren't that different. Body condition scores prior to farrowing, they're about the same. We score them on a system of 1 to 5, with 5 being too fat, 4 being between 3 and 4 being about right. What's interesting is, on the low longevity farm, they continue their theme with the one person's job is to take care of those gilts. In that they have a designated rows in their gestation snake, if you will, that are just gilts. They don't have 2 sows, a gilt, 2 sows, a gilt. A lot of people come in and fill in with gilts where the sows are. They have all their gilts together in a row. Ask them why they do that, and they say, well, it just makes it easier for them to check the gilts because they're all together. So they don't do that on the low longevity farm. When they move the gilts from where they're bred to where they're going to gestate, they move them in groups of 2 or 3 down the alleyways. What's interesting is, again, that same person that took care of them all along, he or she does that. They just have anybody do it on this farm. They use their hands. They don't use a cutting board as that farm. I don't really think that makes a difference. It's just a personal preference. But it's really quite interesting is that these gilts seem to move a lot easier than these gilts. 2 or 3, the guy just walks behind them, touches them, pushes them, and they move right on. Whereas I think they move reasonably well with these as well. Okay. So I asked the guy if he was going to teach him how to respond to a whistle. Then he could just be the Pied Piper and they'd follow him in. And he didn't think he could do that. But anyway, that's a thought. So after gestation, there wasn't anything remarkable in gestation. They get moved into their farrowing barns. Here's how the farrowing barn is set up. It's typically what you see in our large commercial units. There's 48 crates in a room. They're sort of arranged like this. Typically, they try to move the animals in 3 days before their due date or when they're ready to farrow, but they don't always get that done. They don't induce any of their P1 sows to farrow. So they don't use luteolice or something like that on any of their P1 sows. That's kind of a standard operating procedures in this system. So I'll tell you that right now. This is what they look like, the farrowing barns look like on the inside, 12 crates down. The sows do face each other along a center alleyway, so you have a back of the crate here, back of the crate here. The sows face each other here, and then it's a mirror image of that on the other side. And so we're at this part of the curve here where you would expect, if it's like most farms, for them to really start to separate out in terms of which sows stay in production from right here and here. And you can see for the graph that this slope is a little bit steeper and this difference is bigger there. So they are seeing more sows not breed back for whatever reason after the first lactation on the low longevity farm versus a high longevity farm. So here are the differences. Really pretty good. There's only about 5% of those sows that actually farrow, that they don't get rebred on after their first parity on the high longevity farm. There's about twice as many on the low longevity farm. So you saw that slope that way. Again, the temperatures in the farrowing barns aren't really that different. When they move sows from gestation to farrowing, they move them in groups of 2 or 3. Anybody does it, not the person that necessarily worked with the gilts, just whoever's there. On this farm, they use their hands. They don't really use cutting boards. An interesting thing that we've picked up on, and I don't know what this means, but they almost never have any of the sows start to farrow in gestation. Okay. And there's about 5% on this low longevity farm. Now, we haven't gone back to see if the sows that begin to farrow in gestation are the ones that actually get culled out after that lactation. We haven't really gone back and looked at that. But that's kind of an interesting observation. My bias is that it's probably may not hurt, but it surely doesn't help getting a sow rebred. If she starts to farrow in gestation, then you have to run her and the piglets down to farrowing, and she finishes in there. Okay. Assisted sows, and this would just be left up to the technicians to go in and pull piglets if they thought a sow was trouble, or check sows. So anytime anybody goes into a sow, even just to check with a sleeve, they sleeve them, we consider that as being assisted. So the much higher incidence of that on the high longevity farm and the low longevity farm. And retained placenta or pigs, the sows that have 12 and then you're sure something isn't right because they don't start eating, and then all of a sudden you go in and there's a dead pig. Almost never happens on this farm. And 7% probably isn't too bad, but it is statistically higher on that farm. And then the incidence of post-farrowing discharge, we're also taking some information about the health status of the animals, is about the same. Only about 2% of the sows show that kind of thick, sort of creamy discharge after they farrow. And it's not different between the two farms. A little bit about lactation. Most of the time during lactation, they're fed the same diet. Comes from the same feed mill. It's formulated the same way. We are taking feed samples and banking those to see if we need to go back and analyze them for whatever reason. Sows are usually fed to appetite during lactation 2 to 3 times a day. They up the feeding level in the summertime in North Carolina because of the heat and things like that. Pigs are allowed to nurse their birth mother for 24 hours, and then they start to foster. And usually they process the pigs about day 1, and the males are castrated around day 3. Bump weaning is what we use the term in North Carolina. It occurs on the farm where the commercial farms have a certain number of piglets they have to deliver to the nurseries. So if they go in the sows that farrowed this week, they don't have enough quality piglets, they'll go back to sows that are 1 week behind them and pull the bigger piglets off and then reshuffle. So that happens on both these commercial farms. That's a standard practice within this commercial system. It's kind of what a litter looks like that's born a sow from the top down in the farrowing crate. Wire floors, pads, and heat lamps. They do have these little creep feeders for the piglets, but they really don't use them that much. So here are the differences. Again, the same differences in terms of sows' losses during the first lactation temperature. Lactation length was different. It's about a day and a half longer on the high longevity farm versus the low longevity farm. Weight loss was lower, so we're measuring the sows after they farrow and then when they're weaned. So they've probably still got some placental fluids and things like that. But it wasn't statistically different in our analysis thus far. So there is a difference in sort of weight loss, but it wasn't statistically different. Body condition, as we measured, about the same. One thing that was kind of interesting is we try to record daily feed intake or disappearance, and this is more of a qualitative one, but there are about twice as many sows in this low longevity farm, for whatever reason, at some point during lactation go off feed or don't maintain that increase in feed intake, which is kind of interesting. Dr. George Foxcroft at the University of Alberta has done some research years ago where they fed sows, deliberately fed sows different levels during lactation, P1 sows, to simulate this. And what they showed was that any time a sow kind of hits this, I call it hurdle, where they don't consume consistently during lactation, it has some repercussions in terms of their follicular growth and their rebreeding and things like that. So that's why we're kind of interested not only in their overall feed intake, but the pattern of that feed intake during lactation. The bump wean sows, the percentages were about the same, and you can look at the production in the first parity. Really, there's no differences thus far. A little bit better, number born alive, lower pre-weaning mortality, number weaned was a little bit better on the high longevity than the low longevity farm, but those aren't statistically different. I imagine as we get more numbers, if those trends continue with this next replicant, they would approach significance. But thus far, there's nothing different in that regard. Rebreeding, I want to spend a little bit of time on this. It's quite interesting. Sows are weaned into crates. The third day after estrus, at weaning, estrus detection begins. What they do is they back the sow out of the crate into that pen that's behind the Lubbock-style crates, and they have a bore on either side. So the sows get bore exposure on either side, and then they just sort of move down that way. The first mating occurs in a pen, and that's what I showed you with the gentleman on the sow's back. Then they put the sow back in the crate, and then the subsequent matings occur in the crate. So for that first initial estrus, they actually back a sow out into a pen where she has a chance to escape if she's not in heat, but subsequent ones they don't. Okay? And then sows are bred once each day of estrus. So there's the heat detection. You can see there are the pens, there's the bore, there are the crates. They'll back the sow out. They'll check for heat. There's the mating that you saw there. Some of the guys actually have gotten so good that they take their feet and scratch her behind the ears while they're mating her there. The sows seem to like that, I guess. And then there's the mating in the crate. on the day later. So that's kind of how they do things in this farm. So a little bit of differences. Really, nothing remarkable stands out on these rebreedings in the first parity. Designated person breeding estrus, no. Anybody can breed the sows after they farrowed. They're just breeding sows, so they're not breeding gilts and sows, just like it was. And the heat detection is about the same. They use the same bores for the sows as they do the things. So that hasn't really changed. And then the interesting thing is, here's the our mating scores for their mating to start their second period. And again, you can see that the consistent trend here is that there's better sort of estrus response, breeding, mating scores on the high longevity farm versus the low longevity farm. And these actually separate, these actually come a little bit closer together. These have actually slipped a little bit from their gilt matings, and these have actually gotten a little bit better, certainly right here. Okay. So this would be the mating in the pen, and this would be the mating in the crate. And so I'd assume that the mating in the pen would be a lot better because of the boar exposure and the fact that if they try to climb on them and the sow moves a little bit, then they probably can't get the mating done, as you saw. And the mating in the crate, you see, is actually probably a little bit better in some of the things than the mating in the pen for this, but a little bit worse for those. So again, there's our mating system, just to remind you that since we go through it, our mating score there. What I've focused on right now is what we've done here. And I also told you that we've taken some measurements before the gilts came to the farm to kind of describe the gilts from the time they were born until the time they were delivered to the farm, to see if there was anything we could tease apart about what was done before, so that's kind of the developmental phase. And there was some interesting stuff that came out from there. So we looked at the birth weight of the gilts. Okay, so this is the birth weight. Remember, this is all in the multiplication phase. They're all managed the same, and then what we did was we sort of sent them split litters to each of the two farms. Okay, and it's kind of interesting. I think there's a couple of take-home messages here thus far. So this is the interaction between birth weight and farm retention. So these were gilts that were delivered to the farms but not bred. Okay, so that was that first difference that you saw there, the 93%, which was 7%, versus the 83%, which was 17%, right? Okay. And then here are the birth weight categories for the gilts. And then the high longevity farms in the blue, the low longevity farm is in the red. And then I've shown you where there's statistical differences. And here's the percentages that actually fell into that category. So you see it's kind of interesting is the high longevity farm, it's really pretty consistent regardless of the birth weight. Okay. And what's interesting is there weren't a lot of animals in less than 2.5 pounds that ended up being sort of delivered to the farms to be future replacement gilts. But it didn't matter. The environment, whether it was a good farm or a bad farm, for those small birth weight gilts in this system, it didn't matter. So I think the take-home message is that, and I'll talk a little bit about it, is that there might be a minimum birth weight that the gilts just don't have the reproductive machinery by the time they're adults to be a very good replacement gilt. So that might be the first place to start to kind of get those out of the system. But then you see there's quite a bit of difference in the birth weight. And it's these ones in the medium range, which I would imagine that on most of our farms, most of our replacement gilts are probably in this range in terms of birth weight, between 2.5 and 3.5 pounds. And that's where the biggest separation is in terms of how they're managed. And then they're a little bit better at getting the heavier ones in. So why would birth weight be important? And so again, just to remind you, we're talking about this difference right here. It's kind of like birth weight is inversely related to number born alive. And it's kind of like, I call it the crowded pen sort of phenomenon. When you get 12 piglets in a litter, they grow to a certain spot, and then uterine capacity limits them versus if you have 6. So it's been very well documented that not only do they limit the birth weight, but they limit organ development and everything else. And so their muscle mass, the size of the intestines, the size of the brains are all smaller in pigs with smaller birth weights that came from a larger litter. Okay? And so from a reproductive standpoint, we've done some controlled studies at NC State where we've do a lot of embryo transfers for people and things like that, and we collect everything we need to know about the gilts that we use these on. Since we're internal multiplier and all our gilts are born, we keep them on the farm and then we use them for these studies. Well, at NC State in our herd, an animal with sort of in this range of birth weight tends to reach puberty older, has a lower ovulation rate and a lower embryonic survival than one with a heavier birth weight. And they're all managed the same once they're born. Some of them in the same litter. So I think this points to the fact that there's some, maybe the light birth weight pigs, they just don't develop or have the potential to develop their reproductive organs to the point where they can be successful in our modern animals. So, okay. So I'm going to summarize real quickly, and then I'll be happy to try to answer any questions. So what we've done is spend most of our time here. We've talked about this first sort of roll through this functional phase, and then hopefully we're going to get 6 more observations on every animal that stays in production. And I've shared with a little bit about you with what happens in this developmental period. To summarize, there are pretty large differences between gilts delivered to the farm and not bred. The big difference really seemed to be on designating a single person to manage those gilts and then the boar they use for heat detection. Those were the 2 big differences between the high and low longevity farm. There were very small differences in gestation. Statistically, they were the same, 9% and 11%. Again, they had the same person that took care of the gilts from the time they came on the farm in the high longevity farm to actually do the moving. And he used cutting board. He used his hands while other farm used cutting boards. I don't really think that's a big issue, but that was a difference. Large differences in P1 sows that farrowed their first litter but didn't rebreed after their first lactation. And it seemed to start at farrowing, with the observation of how many sows actually farrowed in gestation versus didn't, how many sows were assisted, and the lower incidence of retained repigs. I think that goes hand in hand. Really, it's kind of interesting. If you looked at the overall feed intake, probably wasn't that much different, but there were a higher incidence on the low longevity farm where they had significant periods, 2, 3, 4 days. It was usually in mid to late lactation where they just went off feed. They were bumping around at 10, 12, 14 pounds a day, then they dropped to 7, and they gradually came back up. But that didn't seem to be reflected in body condition losses and weight. And I'll be real honest, when I first started doing this, I expected to see huge differences in feed intake, body condition losses, and weight. And I think we have a genetic animal now that perhaps weight loss and body condition changes, we've learned how to feed them to prevent the really large fluctuations in that. Now there are more subtle things that are coming into play that may be influencing whether they breed back or not. So I think we kind of need to do some more thinking about how do we really measure how well a sow ate and retained her body tissue during lactation, especially in our modern genotypes. And then again, basically the same sort of thing was seen when they were rebred in their first parity as we did as they were bred as gilts. A little bit better estrus response, a little bit better mating response, and it probably was related. And also there was a difference in the boar they used for heat detection. One thing I think, and I'm pretty confident about this, what we found in the developmental period was that there probably is a minimum birth weight, and it might differ from farm to farm depending on the genetics of the farm. But I'm convinced that there's a minimum birth weight that we probably don't even want to consider those animals to be replacement gilts because I don't think they're going to be very successful. And it may take the multipliers of the different systems to figure it out for their own genetics and their own system, but I guarantee you that it's out there. We've seen it now 2 or 3 times on different farms. We've done some other studies on other farms, and it does seem to be a common reoccurring thing. So with that, I have lots of students that help me. I'm the lucky one. I get to think up this stuff, and I get lots of good students to to help me out. One thing that I would point out that I'm really proud of in our program is that we have a lot of students that start out as undergraduates with me, and they go on to pursue graduate degrees or veterinarians, and some of them even become nutritionists, so I guess I failed with those, but anyway. So